Hey, what's going on, guys? In this video we are going to see how to find out whether a BJT transistor is in active mode or passive mode. To find out that one, we can use two of the methods. Like first we can assume active mode and solve for that, and if we solve and if we get a VC that is greater than VB, then this is in active mode. If it's not, it's in passive. If it's not, it's in saturation mode. Okay, and if they ask for IC, IE, IB or anything, and if we assume active mode and solve for this one and found out if it's not in active mode and it's saturation mode, we have to redo everything to find out this current, voltage and everything again. Okay, but here we are not interested in finding this current and everything. We just want to know whether it is in active mode or saturation mode. To find out this one, we can do both methods. I'm going to do the active mode method. So to prove whether this is in active mode or saturation mode, we have to compare this VC and VB. Okay, so if we assume this is in active mode, the voltage drop right here, it's 0.7 voltage, and we use the Kirchhoff voltage law to we have to find out the current right here. Since this is base, we put IB for that. So base emitter voltage is 0.7 voltage, and IB we have to find out that one. Let's go ahead and apply Kirchhoff's voltage law. If we apply KVL right here, KVL here, this one is going to be 2 voltage, and this is negative because going from negative to positive. So this is negative 2 voltage, plus we have a resistor 1k ohm resistor, multiplied this one by IB, and plus 0.7 voltage should give us 0. So from this one we can solve for IB. Now let's go and solve this one. So here you can see this is going to give us 1.3, negative 1.3. Negative 1.3, if we move to the other side, that's going to be positive 1.3. So 1k IB is equal to 1.3, and then IB is going to be 1.3 divided by 1k, that's going to give us 1.3 milliampere. Okay, so that's our IB current. Now we have the IB current, and we can find out the IC current by just multiplying by beta. IC is equal to beta times IB. Now we know that beta is given, that's 100 times IB. We just found it out, that's 1.3 milliampere, and if we multiply both of them, that's going to give us 130 milliampere. And here we are interested in finding, we already know VB is equal to, if we assume this is in active mode, VB is equal to 0.7 voltage. We have to find out what is VC is. To find out the VC, we have a generic formula. VC is equal to VCC minus IC times RC. VCC is this voltage, the top voltage, that is 10 voltage, minus IC we just found out, that's 130 milliampere, multiplied by RC. This is voltage of milliampere. RC is the current, the resistance right here, that's 2 kilo ohm. 2 kilo ohm, and if we multiply this one, kilo and milli cancels each other, we will get negative 260. Negative 260 plus 10, that's going to give us negative 250 voltage. So we have VC negative 250 voltage and VB 0.7 voltage. Since this is negative, this is less than that, so we know that VB is greater than VC. And here what we have to have is, we had to have VC greater than VB in order to be in active mode. Since we found out VB is greater than VC, this is in saturation mode. That's all we want to know. Here we are trying to find what is the mode of this operation. Find the region of operation for BJT. So they are asking for the mode of the operation, that is saturation mode. Okay, that's all we want to find out, and that's it. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electronics or circuit analysis, any other thing that's related to BJT or any other circuits, it's all in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.